going to try to do this. It's going to be hard to see, I think. White. That's good. Take your baking soda, and you're going to put it in the paper towel, just kind of in the middle. Can y'all see that? It's like they go to work. Everybody's moving. You get a lot done. Yeah, I see some thumbs. It's good. I'll try to hold it up.
My paper towel.
See my baking soda in there?
Oh, I see.
Okay, so now what I'm going to tell, I'm going to explain this, and you can use your own judgment, but I'll try to guide you. What we have to do is we have to put vinegar. Don't do it yet. I'm explaining it. Okay, I think I'm thinking about that. We're going to put vinegar in the bag. We're going to take our paper towel. I'm just demonstrating. This is one without any baking soda on it. We're going to have it folded in such a way that we can put the paper towel inside the bag without letting the baking soda and vinegar touch each other. If they do, the reaction will start. We can't have that happen yet. Once we get it in there, we're going to hold it with our fingers so that it hasn't released yet, and then we're going to seal the bag. Once the bag is sealed, we can let the paper towel go, let the vinegar mix with the baking soda, and then hurry up and run outside and throw it away because it's going to blow up. Did everyone catch all of that? Yes. Make sure you're outside before they mix. Everyone good? Everyone follow? I have thumbs down. Uh-oh. Jaegers, what's going on? Okay. So, question. We got to get this figured out before we do it. And we're going to roll it up.
In the bag.
Can you repeat the steps, please?
Can you repeat the steps?
Okay. So if you have your baking soda on the towel, kind of fold it up so it's kind of small. You can do that. Make a Tootsie Roll out of it. We'll just do this step by step. You want to make like a little pocket for the vinegar, for the baking soda to go in. It's like a little capsule. That's what we're making. It's a little capsule for the baking soda. Okay, I see some capsules. So if you've got your baking soda ready, give me a thumbs up. And show them to me. Okay, Haynes, look good. Everybody looks like they've got them ready. Okay, so set them aside. Now I'm going to demonstrate without vinegar, so don't just watch, don't do anything. So I have my capsule, I'm going to put it in the bag. We're going to pretend that this bag has vinegar in it, but it really doesn't. And you might have to help each other do this. You need at least 3 hands. See, 2 hands, it would be blowing up in my face. So once the bag is all sealed, we'll kind of. So the vinegar will be down here. And just shake it, get it to just unmix. If it's too tight, it might not work. But the vinegar is going to react with the baking soda, and the bag's going to blow up. So make sure before you do this, you're outside somewhere where you throw it away and it won't hurt you, it won't blow up and make a mess. Okay, did everyone get that? Does that make sense?
Do we do it?
I see is that someone raising their hand. Okay, what's your question?
Can we, what size scoop do we use for the vinegar?
Good question. We're going to use a half a cup. Good. Good. Everybody's got it? Nobody's going to lose an arm or hand or anything today? Good. Okay. So now, take your empty bag, nothing in it, and your vinegar, and your measuring cup. Get a half a cup of vinegar.
Completely or not completely?
Okay. So,
Time to put it in the chat box or unmute yourself.
Hey, Laura, you
Y'all
can
have a
unmute your.
Haynes family, do you have a question?
Do we use all of it or not? Like the full cup of vinegar?
Half a cup. 1/2. 0.5.
Can we put it in yet?
Heather's iPad. Can you mute your mic for us, please? I'm talking to you. But,
Hey, Justin. If anybody
Okay, I
has
think
those
they're
like
getting ready.
okay, so I see Sawyer and Kira. They've held up. Does everyone see Sawyer and Kira's bag?
That's just a chip clip.
That's how we're gonna do it. They use apple cider vinegar.
Yeah.
They got the fancy stuff. So when you've got your vinegar, this is the part you have to be careful, because now you're about to start mixing two chemicals technically, and they could go off. So be ready. This is what you want to do outside. So if you're ready to launch your bomb, go outside. Now remember, this is a cold gas. I see cameras moving, so it looks like they're going outside. I see somebody have their hand up. Haynes family, what you got?
Can you wait for us to get our stuff? We had to move outside because we were in the house.
Yes, you can play.
You all need us to wait?
Yeah.
Okay.
We want to go ahead and get set up outside.
We can. Is everyone ready? Everyone get your bags and your vinegar and baking soda. We're gonna go outside. They want us to wait to do it. Y'all still hear me? I have no idea. Okay, so when are they going to be ready? I want to watch them though. Well, I can't see much. Okay, so if you're ready to do it, you go ahead and do it. But make sure you throw it away from somebody, away from animals and stuff, so that it won't hurt anyone. And go for it. And now I'm going to watch you guys. So what you're going to do is you're going to still hold the pouch, seal it up good, mix it all, a lot, and the bag's going to start to expand because now you're creating cold gas. Your gas is starting to build up inside the bag, and it's going to pop. See Eli mixing it. So if it starts to blow up, Eli, throw it.
So are we allowed to do it now?
Thumbs up.
We're ready.
I can't even hear you. Can I? Yeah. Tell them how to do it? Yeah. So half a cup of vinegar, put your baking soda in a paper towel, hold it in there, see it's inside the bag. Seal the bag. I'm gonna try mine, we'll see how it goes. And then get it to mix up. Oh.
You want to explain what happened?
Okay, so I'm going to approach the site carefully, and we're going to assess what went wrong. Okay, did y'all see how big the bag got? Now what happened was, if I squeeze the bag, it's leaking. So either I didn't seal it right, or the bag popped and it leaked out just enough. But what needs to happen is the pressure needs to build up and build up and build up, and then it needs to pop all at once. I think either that or my bag was had a hole. We're gonna try again and see if we can get a pop.
For some reason, my brothers won't pop. My brothers won't pop for some reason.
Okay. So before I do it again, did anyone else get their bag to pop? Give me a thumbs up. All right, Eli said yes. Sawyer and Kira said yes. Jill said yes. Yeager said yes. Balin said yes. Luke said yes. All right, so we got some explosions. Does anyone have any questions? Has anyone not gotten it to work? Okay, I see Luke has a question, but I'll Miss Starlin's in there. Okay, Luke, you got a question?
But it did fill up. It did fill up, but it didn't blow up.
Tell us your question, Luke. Luke? You should be able to ask her another thing.
Says that my little brother says that his didn't blow up like he was supposed to.
Mine blew up in my hands.
Mine blew up.
One blew up and one didn't. Okay, so we're gonna try it again. I don't want to watch one blow up. I want to watch mine blow up. And then I want you to feel the bag after, if you can, after it. And is it hot or is it cold? We'll revisit that later.
It's cold. pointing right there. I know you're still on mute.
Is
Mine didn't work again. You can see the bag stretched a lot right there, but it didn't go. Well, that's okay. I know what it was supposed to do. So if you have the chance to feel the vinegar after the reactions happen, you'll notice it's really cold. So keep that in mind. All right. Can everyone hear me? We good to go?
Just the kind of balloons.
Still, yeah, the balloons will be fun. Okay, so whose bags did not work? I did raise my hand, but mine did not work. But it was faulty equipment. I still see some people out in the field, so when you're ready to move on, give me a thumbs up. I want to see a thumbs up from everyone. Eli Bean has ceased to exist. Oh, there he is. And a thumbs up.
Some hyper kids.
Okay, yeah, we're blowing stuff up. What do you expect? Luke's iPad. Where did you go? This is a very nice backyard. You good? All right, good to go. Okay, so that was a demonstration of cold gas. Now, what do you think, and I want you to raise your hand and answer this question, what do you think cold in cold gas means? You can answer this. You can chat, you can type, or you can raise your hand, unmute, tell them to start.
The decompression of the gas makes it cold. So, well, I think, and that's black.
What's the decompression of gas?
That's exactly right. So when you compress something, it gets hot. When you decompress it or expand it, it gets cold. So what happened to the bag? Did it compress or did it expand? It expanded. So we created a gas from the baking soda and the vinegar. We created a gas. Does anyone know what gas we created? Raise your hands.
Carbon dioxide?
Carbon dioxide. That's exactly right. So in a cold gas thruster, we don't use fire, we don't use gasoline, we don't use anything that explodes. All we use is a gas that we create without fire. There's no combustion, there's no burning. So if we want to turn that into a force we can actually use, we're going to need a thruster because we created a force, right? We created a force, and if your bag expanded and it popped, that's a force. But could we put this onto the bottom of a rocket and launch the rocket into space? Well, maybe, but it would be very hard. So what we have to do is we have to take that force, we have to capture it, and we have to send it where we want it to go. And that's what we're going to use the balloon experiment to demonstrate for us. So everyone has a balloon and a straw.
Oh, I need a straw.
String.
I need a balloon straw.
Piece of tape. I see stuff coming out of the woodworks. Okay, so let's do a demonstration. Now, if you let this balloon go, can everyone go and get it? It's not going to fly away, but is it? Okay, so everyone blow up your balloons. Excuse me.
Stop. Stop arguing. I'm trying to. Did you ever
Eli,
get a straw?
can you mute your mic? Thank you. So how do you attach the straw to the balloon? Just like this?
I just paid for it.
After it's blown up?
I did it before.
Before it's blown. It's been about 15 years since I've done that. Yeah. Well, I won't do it yet.
Okay.
All right, does everyone have a blown up balloon? Got air in it? Okay. Let it go. And then go and get it.
Different shapes of balloons.
I know everyone's got different balloons. All right, so what happened? The balloon flew away, right? How did it fly? How is it able to move? What pushed it through the air? You can chat the answer or you can raise your hand.
The air that was inside it was pushing out the other air that was getting
See,
blown out.
Did Luke's
because
iPad, did they say something?
So it blew away.
Luke's iPad said that the air coming out the air constituted.
Exactly, okay. Eli, what did you have to say? Where'd you go?
Air compression.
The compression, okay, so both of those things. So the balloon, it's hard to blow up a balloon, right? You actually have to put some effort into it. So the balloon compressing the air forced the air out the end of the balloon, and that propelled it through the air, right? Exactly. So this balloon with air in it, and this whole thing, this is a thruster. Okay, so we've taken a force, which is the balloon pushing on the air, and we've directed it out the end of the balloon. We controlled it a little bit. The balloon just kind of flew wherever it wanted. But it controlled it, and that is a thrust. So let's do the string. So the balloon, so you guys are probably familiar with this. You're going to tape a straw to a balloon, and you're going to run it through a string, and you will string, to make the string. Don't make it too long. We'll be here all day, but, we're going to do that. So get busy. I guess blow up the balloon first, right? So get your balloon. You might want to put your, no, you got to put the straw on the string first. But you can get the string taped
Yeah,
to
you
one
can
side.
take one side of the string.
That will-
Hold the straw.
We're going to tape one end of the string to the wall over here. You guys can hold it between two people, or you can tie it up across your house. So now we got to put the straw on this. And then
Ask Matthew Satchfield.
okay, so I need to stop and I need to pause. Matthew, are you lost? Which one's
My speaker cut out. I couldn't hear what you said.
what do you say?
He said the speaker went out, we didn't hear what he said.
What part did you not hear? Did you like how to do it or what we're doing?
How to do it.
What we're talking about?
Yep.
How to do it. So we're gonna tape one end of our string to the wall, or you can tie it around a pole, or have someone hold it. And then we're gonna take a balloon, we're gonna fill it up with air, and we're gonna take a straw. And we're gonna tape the straw to the balloon. Now, notice how I tape that straw on it. It needs to be in line with thruster, right? If you taped it on sideways, it wouldn't really go.
It was too hard, my whole straw.
So basically just like that. So can everyone see? Matthew, is that, you got that? All right, I got a thumbs up. Who has done this before? I have like 15 years ago. I see a hand, I just see this. I see like that. That's all I need, that's good. So we'll wait till everybody gets your balloons, your straws on your balloons. Sanford, you guys have a challenge because straws are straight and your balloons are not. Yeah, so y'all are gonna have to maybe,
Just see what
and I
happens.
see some others, those people.
Some of your
JP
straws are different
groups.
shapes.
So somebody, so look, I should have used the orange one. Some people have the fuel tank from the space shuttle, and some people have the solid rocket boosters, but that's okay. I get it. I don't want to go too, I don't want to do it yet. I'm doing this, so. I gotta get it through there somehow. Maybe.
You can cut the tray in.
Yeah. So your straw, if you haven't put it on yet, you can make it shorter or you can make it longer.
Get it before it's ready.
Don't do that. All right, so is everyone following along? Is anyone stuck? See, the Sanfords are performing surgery on their balloon. There's some serious operations going on there. Great. We did. One second. So it might help if the string is longer, because then it'll be a little more stable. But or not the string, the straw. But if the straw is shorter, it might go a little faster because now there's less friction for the string to rub up, less area. So does anyone have any questions? Does anyone stop? Johnsons, are y'all good? I thought y'all had raised a hand.
We're just gonna watch. We got the long.
Sanford's, how's it going? They had the, yeah. These are easier to blow up. Yeah. Okay, so is everyone ready? Give me a thumbs up. Uh-oh, I got a thumbs down. All right. Oh, I got a thumb sideways. Yeah, 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 yeah. You're just gonna see a balloon just go. All right, so I'm gonna get this real close so y'all can see what it's supposed to look like. So there's a fly on the microphone. So you see how the string goes through the straw, and the straw is attached to the balloon on the same axis as that. Has everyone got that? This is just like launching rockets at nationals, because we might be ready to go, but there's one thing we have to wait on, and you're just like, let's go, let's launch the rockets, and we're still having to wait. There's always a problem. Okay, so if you're not good, if you are not ready, get the thumbs down. Okay, I still see some thumbs down. Okay. Okay, so if you're ready to go for it. Launch your balloon rocket. It should look something like this.
I think we need to see a rerun of that.
Everybody launch. Does everyone catch it? Is everyone ready? Launch your balloons.
Don't move on. I'm not ready.
Balin, how's it going? Okay, the one that's named Balin. Can you hear me?
Yes, we can hear you. Can you hear us?
Yes, you can hear. She's talking to you.
Y'all good? Any
Yes.
questions?
Don't shake your head, just shake the camera.
Our computer cut out. We're having some stormy weather or something outside and our computer glitched. So we missed, what do we do with the string?
What do you do with the string?
How to set it up so the string goes through the straw. So you're going to have to leave one end of your string not attached so that you can string it through the straw. And then I have it taped, we have it taped on that end so that I can pull it tight. And I'm just going to hold the string, then when I'm ready for my balloon to go, I'm going to launch it.
Ask her, ask her if she understood it.
Did you get that? I have a thumbs up. Cool.
Help or not looking at the camera and
Huh?
does it help to look at the camera and the lock up or doesn't matter?
I guess it matters for them. I just like to watch them. It's killing me not to have them either. I miss the interaction with the social. Has anyone launched? Oh, I saw a balloon just go crazy on the screen. I saw a few streaks of purple, and that was it. I think that might have been a mislaunch there, a misfire. Okay, Mr. Bean, good luck getting that on a straw, sir. It's really cool, but I don't know if it's going to work.
Oh,
Did you
we've already
make
launched
that?
those. No, my sister did.
What did he say?
She said his sister.
Sister made it? That's pretty cool. If you could put that on a straw and make it go across the room, I'd be very impressed.
I probably could, but I've already launched mine. It
Has
went about
anyone
500
gotten
miles
their
per hour.
balloon? Sorry, you were saying something.
He said he already launched his.
You already launched.
500 miles.
500 miles per hour. That's pretty fast. If you can get it to 767, you'll break the speed of sound with the balloon. So I think you should try again.
Let's try it.
Has anyone else gotten theirs to work?
Nathan's ready to go.
I think they all have.
If you're ready, go for it. Do it. I see the Sanford's going backwards. That's interesting. Nathan and Matilda, is y'all ready? If you're ready, go for it. Launch it.
Show on here?
Still blowing it up. That balloon is almost completely transparent, dude. There it goes. Awesome. Anybody else ready? I see a thumb. Go for it. I want to watch. I want to see him go. Oh, there goes. It's just balloons just going. Pew. It's all I see. Did it not work? Did anyone's not work? Give me a thumbs down if it didn't work. Okay.
Tracy offered picture, and she said it was great.
Awesome. What's that today? No, I didn't see it. Okay, so while everybody is still getting theirs to work, I want you to raise your hand and answer or type it in the chat. What did this experiment demonstrate? Okay, Mr. Touch screen. Second law of aerodynamics. So what is the balloon? What did we talk about? What does the balloon act as? Equal out. That's Newton's law. One of them. I don't remember. There's so many of them. What is the balloon acting as?
The thruster.
I see the Sanfords raise their hand.
The thruster.
Phelan raised his hand. Thirster, Eli Bean. first or Newton's third law, every action has an equal and opposite reaction. Be right back. That is not the right answer. So this was acting as a thruster, remember? So we put air into the balloon, and the balloon compressed it, forced it out the end of the balloon. That made the balloon go across the room, and it acted as a thruster. So did everyone get theirs to work? I want a thumbs up if you got it to go across the room. Thumbs up. Perfect. Okay. So now we've explained cold gas with the baking soda and vinegar and a thruster with the balloon. So now we're going to put them together and we're going to put it inside of a rocket. And we're going to launch the rocket with a cold gas thruster. So this might take some time. How much time do we have? Okay, so this might take some time. Now, does everybody have a little container, like the M&M container, or a film canister, or even a Play-Doh can? Yes, I know. She got in your purse. Eli Bean asked if he can do something. What's he going to do? Really? Pour some money? So what did everyone manage to find? I'm just curious. Did you find a film can, or did you have an M&M tube, or what? M&M tubes. I see Play-Doh M&Ms. Of course, y'all went for the M&Ms. You can eat them.
I have M&Ms.
Yeah. Okay, so somebody does have film cans. Well, I saw some Play-Doh containers. Okay, so if you have a M&M tube and it still has the lid, you're gonna have to cut the lid off. And I already did cut the lid off of ours. Yeah, you're gonna need the lid, but just cut it off so that it can completely come off of the tube. If you have a film can or a Play-Doh can, you should be fine because they are already separate. So if you have a film canister, that's the best one, probably. Now, it's not very long, so you can see next to that rocket, it's not going to be very big, but it will give you the best results. But if you have the M&M tube, the M&M tube will work too. All right, so if everyone's got a canister, go ahead and you can decorate it however you want. I have aluminum foil. I took a piece of paper and I twisted it in a cone. I cut it. I'll show you how to do it, but I cut it, put some tape on it. I put some little pins. So just decorate it how you want. I'm gonna try to decorate this steel canister. It's gonna look really weird because it's so short. So, but this, you don't need instructions. Just go wild, but make sure that the lid on the can can still pop off and that it's on the bottom of the rocket. Does that make sense? Does everyone understand that?
You guys will be able to see your thing?
I guess. No, they can see it.
Yeah, it's just a.
Yeah, that's fine. Got thumbs. So go crazy and just build a rocket. Decorate a rocket. These are some tricks that I found. I put 3 fins on mine, mainly because it's less than 4 and more than 2. But I had the feeling that if you put 3 instead of 4, you can get your fingers in to put the tape on, because that's what I use to hold them on, just tape. You can wrap them in foil if you want. I wrap the nose cone in foil because I thought it was cool. We are going to be using water inside of these rockets. We're going to put water in them, so they might get a little wet. So keep that in mind if you're using something like paper. So for the nose cone, I just took a piece of paper, or a cereal box, or just whatever you want to use, whatever you had. It's not really the easiest thing to do, and I know there's templates out there, but I just kind of like twisted it up in a cone, and I just cut it. Everyone's good. Everyone okay? Makes sense? This is your time to do just whatever you think you want to do. Doesn't have to be anything particular. You don't even have to make it look like a rocket, but I think you kind of want that to fit on top, which is too small. So try again. Looks. It's all for looks. There is an aerodynamic effect, but for this project, these rockets aren't going fast enough for a nose cone. And the fins, what would the fins do? I want someone to answer me. What will the fins do?
Stabilize the flight.
Stabilize it. Now, we can't control these rockets, but on a big rocket, they can also control where the rocket's going to go. Like big ones, like the space program rockets. Let's keep on here. So y'all know about Apollo 11, right? Yesterday was the anniversary. Yes, yesterday, 51 years ago, Apollo 11 landed on the moon. And spoiler, they did not use one of these. Didn't quite look like that. It looked pretty close, okay? You could paint this to look like the rocket they use, and you might fool someone. No. So what would be the purpose of the nose cone? Why would we put a nose cone on a rocket? Why wouldn't we just launch it like that? You can answer this question. That's when they're going this direction. This. That's next week lesson. I'm not really having any luck. So. Yeah, everyone's working. Is anyone having any success? I see a fin go across the screen. I saw a couple of nose cones. I see cereal boxes sitting on the table. Yeah, you have time. We'll give you 5 more minutes. It doesn't have to be pretty, but we need some sort of stabilization. I mean, this rocket might reach Mach 2. We have no idea. What was that?
So we're just making the rocket.
What's that, Brandon? What is that?
So what exactly what we doing right now?
Nathan and Matilda, how's it coming? Good?
So, we don't know exactly what we're supposed to do.
They say something.
We don't really know what the rocket is.
Okay.
Your
So do y'all have,
decorating.
Nathan and Matilda, do y'all have your M&M tubes?
Yes.
Okay, did you cut the lid?
Yes.
Yes.
Cut off the lid?
Yes.
They did, okay.
Yes.
So do y'all want to decorate it? See, what I did is I took a piece of paper
Okay.
and I made it in the shape of a cone and I put some foil on it and then I taped it to the rocket just to make it look like a rocket. So do y'all want to do that? Y'all probably have a little bit of time.
Okay, so we're decorating.
Okay, so go for it.
Thank you.
So I'm going to show you guys how I made a nose cone. And I'm an engineer, not an artist, which means my stuff will work, but it won't look very good. So I took a piece of paper that kind of is about like that, and you're going to kind of fold it corner to corner. I really can't explain how you would fold it, but you're just going to make it look like a cone. Y'all see that? Bryn, what are you doing with balloons in your mouth? So then when you get it like this, you're going to have to kind of hold it, see the edge there, and tape it. So then when you get it taped, it'll stay by itself. So now you have a cone. So then this is kind of tricky. You just kind of have to guess. Wherever this is the same size, you want to cut this, you want to cut this. I'm going to cut it off somewhere in here so that it's flat. This is too big, so I'm going to have to cut it again, but you're going to keep cutting it off until it fits around the can. And it might not look very good, it's not very straight, but when it'll kind of fit around the canister, use this one. That's pretty good. Make sure you do not put it on the opening. In with the hole in it, don't put it there. Put it on the other end. Because remember, this is our thruster. So we're going to give y'all 2 more minutes. And how's everyone doing? How much do you have done? Show them to me. Okay, so I see a rocket with some fins. Looks like a sausage link. It's good. That one's cool, Mr. Bean. So is it open on one end? Did you guys make sure to leave?
Can you still put the lid on?
Can you still get the lid on the tube?
I think she just realized.
Keep trying. Make sure that you can still put the lid on the tube. Then I'm just gonna wrap it in some foil. So it looks cool.
Make sure you don't put the nose cone on the lid.
Did anyone put the nose cone on the lid? Okay, so look. Here's my rocket. Get real close. So here's my nose cone. And here's the lid. Okay. I can take the lid off. So that's what it needs to look like. I need to still be able to put the lid on. The M&M tubes have a lip. See the lip around the end? So you can put your fin, pretend this is my fin. You can put your fin right up against that lip, and that's perfect. Just like I did there. That's just a good reference. You can put it anywhere on the rocket, but why would we put it at the bottom of the rocket and not at the top? Why are the fins not the top? Answer that. Does anyone have an answer? Raise your hand or type it in the chat. Why do we put the fins on the bottom and not at the top? Okay, Whitaker family, do y'all have a good answer?
I think because it might create more drag.
Create more drag. Okay, so the fins will add some drag. But why would we put them on the bottom of the rocket, not on the top? Balin, do you have an answer?
It'll make it go slower.
It might slow it down, but that's not why we put fins on it.
Brady says more stable. And one other one said creates it to be top heavy, put it on the top.
Okay, Nathan and Matilda, y'all are raising your hand.
I think it's because since the thrust comes from the bottom of the rocket, that's the part that you want to stabilize.
What did they say? What did they say? So you're saying where the rocket, where the engine is where you want to stay. Is that what you're saying? Yes.
Or where the
Okay,
thrust.
does anyone else have an answer? Stabilization, well, that's why we have fins on the rocket. Yes, but why are they on the bottom? Why can't I put them on the top? I mean, if the fins are on the rocket.
Because they'd be.
You could, but it's not quite what I'm looking for. Okay, Nathan and Matilda are raising their hand again.
Well, it'll, if you put it on the bottom, won't it make it more like aerodynamic?
That's close. So let's pretend that the rocket's going through the air really fast. If I put the fins at the top and the rocket starts to lean a little bit, so let's pretend the rocket's going up like this. If I put the fins at the top and it starts to lean a little bit, the wind is going to catch the rocket and it's going to flip. On an arrow, for a bow and arrow, where are the little feathers on the arrow? Are they on the front of the arrow or the back of the arrow? They're all raising their hands.
Sanders are raising their hands. Leaders are raising their hands.
Okay, Sanford's, what's your question or answer?
They have it on the bottom of the arrow to make it fly straighter.
Back of the arrow.
Make it fly straighter. Have you ever shot an arrow and the arrow kind of comes off the bow and it's going all crazy, but then it straightens itself out and it flies straight and through? That's why they put the feathers on the back of the arrow, because it's going to stabilize the back of the rocket and it's going to make it fly straight. The fins are on the front of the rocket and it starts to wobble, it's just going to tumble. Does that make sense? Does everyone understand that? Okay, so is everyone done? Everyone have a rocket? Thumbs up, give me a thumbs up. Give me a thumbs up, give me a thumbs up and show me your rocket. I want to see it. Got some tall rockets, I got American flag rocket. Got some rockets with long nose cones, some with really long nose cones. Wow. Mr. Bean, I think you cheated. He's like, oh, yeah, you cheated. Used a real nose cone from a real bottle rocket. That's all right. All right, so is everyone ready to
There was no
build
rules.
a cold gas thruster rocket? Got some thumbs up. Okay, so now this is how professionals clear the workspace. Just like this, just shove it all over the way. Get a nice clean workspace. So you're gonna take your rocket. Make sure you have the cap still. If you don't have the cap, this is gonna be really hard. By really hard, I mean impossible. Now you should all have some of these tablets, these seltzer, what do they call them? Alka-Seltzer, yeah, Alka-Seltzer tablets. Does everyone have some of those? Good, okay. Everyone is gonna get one. So everyone needs one for their rocket for this time around. Just set it aside. You're gonna take some water. Now this is not the vinegar, just so it's clear. This is just regular water. Now this is the part that might get a little wet. So we're gonna do this outside. So make sure before you mix the tablet in the water, you're outside and you're ready to launch your rocket. Now I'm gonna pretend, and I'm gonna show you how you're gonna do it. You're gonna fill this, you're gonna fill your tube up with about a third, we decide on 1/3, a fourth. No, they can't put a fourth of a quarter cup in that. It's a fourth of the tube. So you're gonna fill your tube up about a third to a fourth of water, okay? And then when you get ready to launch it, you're gonna have to go fast. If your tablet will fit in the lid, that's pretty good, because then you can take your lid and you're gonna pop it in, you're gonna put the lid on, set it upside down, and you're gonna stand back.
You're gonna do it quick.
You gotta be quick. Did everyone get that? Do you know what you're gonna do? You can put the tablet in the lid, or if you can be fast, you gotta be fast. You can just put the tablet in the rocket, put the lid on, turn it upside down, put it on the ground, and stand back. But you gotta be fast. Does anyone not understand? Give me a thumbs down if you don't understand. I see people going outside, so I think they're ready. You can use mine.
Yeah,
Or no,
well,
you can use, where's the vintage?
On this one, if yours goes off this one.
Yeah, it would fit
It
this.
was pretty much.
The film canisters, yeah. They're a lot of fun. We had All right, so I see everyone going outside. So whenever you're ready, go for it.
You're not coming?
I am. Sorry.
They've been waiting for a while. Look at this, it's quiet out here too.
Okay, so is everyone getting set up? Looks like everyone's gone outside. So whenever you're ready, go for it.
Flip it on you.
All right, did y'all see that? So my M&M tube, the lid is kind of loose, so it doesn't have a chance to build up enough pressure and pop off. Now I'm going to try it with a film can. Y'all catch it?
Good job. There we go. Uh-oh, we about got one in the pool. He's using the pool to fill it. It's creative.
It's pouring.
Guys, notice the tractor. We will be having an equipment video tomorrow. Stay tuned for that. On the table? No go.
Okay, did anyone not get their rocket to work? Has anyone got any trouble? I see Balin's saying thumbs down. Balin, what happened?
Mine would it didn't work.
Luke said something. What did Luke say? Oh.
Ours started leaking and but it's building up pressure now. But it dissolved while we tried to put it back in another thing. It's still trying to blow up pressure.
Oh, you got a putty.
Need it. What? It worked. It worked.
What did Balin say? Balin, what did you say?
It worked?
It worked. Yeah.
Awesome.
My mama threw it on the ground and then it started popping up and then it went to the air.
How high did it go?
Like
Did it hit the stratosphere?
10 feet.
10,000 feet? Wow.
10 feet.
10 feet. Oh, well, that's still pretty good. Bryn, how's yours? Does yours work? Thumbs up? She's like, oops.
Still blowing balloons.
I can't hear you.
Sorry, we have to find a better canister. We didn't have the right size, so we'll be launching ours this afternoon.
Okay.
Try to do it over and over.
Yeah.
Different canisters.
So later, tomorrow or later today, if you can find a different canister, if it didn't work as good, you could try again. The tighter the seal is on the canister, the more pressure will build before it pops, and the higher it will go, theoretically. Yeah, I'll ask him, but I didn't even feel it. So the vinegar and the baking soda does it.
Unless the seal is too strong.
So if the seal is too strong, that might be an issue, but what you can try is different amounts of water, and maybe you can crush up your tablet. Because if you crush the tablet up into pieces and then put it in, there's more surface area of tablet, and it'll build up more gas quicker. Yeah. If your rocket builds more pressure before it pops, it should go higher. And if you had a chance to feel the tablet after to see if it was cold or not, you should feel it should be a little cold and nasty. We'll go inside.
Wait, Scarlett. Wait. Thumbs up. You can talk.
I have a survey I'm going to put in the chat.
Somebody said they had a question.
I see Nathan and Matilda, if y'all have a question.
Okay, so I was wondering, what makes or I forgot the word, but like when you use the Alka-Seltzer tablet or baking powder and water, what makes it like the cold something versus like a hot?
He wants to know whenever you mix the water and the Alka-Seltzer together, why it's cold instead of hot.
Okay. So, do y'all remember when we did the bag? Somebody answered this. Somebody said it in the video. When the vinegar and the baking soda mix, what happened to the bag? Expanded, right?
It expands, yeah.
So when things expand, what happens? They get cold. So the reason we call this a cold gas thruster with the rocket is the Alka-Seltzer tablet and water mix. And guess what gas it creates? I want y'all to answer that. What gas do the two create? Where's my tablet? So the Alka-Seltzer and the water, when you mix them together, what gas is it creating inside the rocket?
Carbon dioxide.
Somebody said carbon dioxide.
Carbon dioxide, that's it. So is carbon dioxide, is that flammable? Did we get our rocket to launch in the air with fire or any type of gas or gasoline or any type of fuel? Did we use
No.
any of that?
No, but
We didn't, right?
the whole.
Only use cold things. Now, just because it says cold in the name, cold gas thruster, doesn't mean that it's actually cold to the touch, like ice. It just means that there's no heat involved. There's no fire. There's no combustion. There's no burning of anything. So that's why we call it cold gas. And the thruster, which we demonstrated with the balloon on the string, is how it propels itself forward. So the cold gas building up inside of the rocket pops off, and this tube acts like a thruster, and it causes the rocket to go up. It didn't just explode and go out, it went straight up. So that's what a cold gas thruster is. And in both of these experiments today, the cold gas that we used was carbon dioxide. So I guess that's everything that we were going to cover.
One last thing.
Go ahead, Eli.
Earlier he said if you can make that dog fly across the room, I'd be impressed. We're gonna make the dog fly across the room.
Okay, so everyone, Eli is going to demonstrate a dog in spaceflight. This is history in the making.
Oh, it didn't work. Oh, it didn't work.
Oh, there's a dog.
There you go.
The dog's named Luna.
Yep.
You should name the dog Luna.
Okay, in the chat box, Christy has put the survey that we would like for you to fill out, the link to the survey.
Skeleton.
So you can click on it and then do the survey right now. If by any chance you miss it, I believe that Miss Christie will be emailing it to you. But all you have to do is click on it right now and you can fill out your survey.
Okay, then before y'all go, there's one thing I want to talk about, and this is just kind of a fun thing. Does everybody know what SpaceX is? Raise your hand if you know what SpaceX is. Okay, does everybody know what Tesla is? Yes. Okay, so you know that the person that owns SpaceX, Elon Musk, also owns Tesla. So the companies are related, right? Yes, right, yes, okay. So on one of the new Tesla cars, the Tesla Roadster, Elon Musk said they're going to make a SpaceX package. So you can get a special edition car. And what he's going to do is on the license plate of the car, behind the license plate, he's going to have cold gas thrusters on the car. And they will actually function. They're going to be real. And it'll actually make the car go faster. So there is going to be, in the future, a real car in the world that uses cold gas thrusters. Now, they might use something else. They could use carbon dioxide, or they could use air, or they could use something else. But you can look at that car and know that it's the same kind of system that we demonstrated today. So be on the lookout for a Tesla Roadster with a SpaceX package featuring cold gas thrusters.
Justin, we thank you very much for being with us today. We hope everyone had a good time. You guys really good information. The exercises. So thank you.
Y'all are welcome. Thank y'all for tuning in, and I hope you had a good time. I had fun.
Do your surveys, guys.
Yeah, do the survey. There's some cool questions.
They're in the chat box.
Bye.
And you can leave. See you later. Yep, this is Houston, Michigan.
Just click that link and it ought to take you straight to it.